Question number 10, it said solve each inequality by graphing its solution set on a number line and then write the solution set in interval notation. This is one of those problems where you have lots of choices on how you're going to solve it, but the first thing I would do, I would just go ahead and convert this thing into an equals. Really what we want to do is we want to find out where is our equation exactly equal to 0. Then we'll come back up here and we'll interpret when it is greater than or equal to 0. So I have choices here, and my choice of preference on this one, I can solve quadratics. I have three choices. I can factor, I can complete the square, or our third choice is a quadratic formula. Now the quadratic formula always works. Complete the square always works, although it's not always my first pick, especially if this number is odd. And factoring, if it does factor, is my favorite choice, so I'm going to go ahead and try to factor. Trinomials are factorable, factor into two binomials, and x squared has to be x times x. The signs have to be different. They must be plus and minus. Factors of 8, that will give me a positive 2. If I do 4 times 2 is 8, and 4 minus 2 is positive 2. That would give me the correct factorization. Then, we know that if two numbers are multiplied together and their answer is 0, one of these two numbers has to be equal to 0, so x plus 4 equals 0, or x minus 2 equals 0, which means x is a negative 4 or x is a 2. Now what these are the important points that we have to find, because that tells us exactly where our answers are 0. So all we need is one number line, because there's only one variable in here, and that one variable is x. There's no y. So our anchor points in our graph are negative 4 and a positive 2. These anchor points tell me exactly where are the inputs that give me an output of 0. So this is an output of 0, and this gives me an output of 0. Now I'm going to come back and start interpreting what our graph is. We have a parabolic curve that is a U-shape, and the U-shape is smiling because it's a positive x squared. So because it's positive, we're going to have a smiling graph. This graph, when I put that in there, helps me interpret this inequality sign of greater than or equal to. So now what I'm looking for is on my graph, this is where it's exactly 0. In between these, in this area right here, my graph falls below. So these are below 0. So if it's below 0, it is less than 0, or they're negative. So there's three interpretations that we have there. If I go to the outsides of these things, let's see, what color is going to show up here? Maybe red. Well, if I go outside of here, now my graph is above. Since it's above, then it has to be positive, and if it's positive, sorry, not posse, got distracted by the 0. Positive, then that means it's greater than 0. So I also have that situation out here. If we pick any x values on the right of that 2, we get y values that are greater than 0. So this is when it's above, or positive, or greater than 0. So now I just have to figure out what kind of values we want. I'm coming back to my original equation. Going to observe this one more time. We have x squared plus 2x minus 8 is greater than 0. We want to know when is our parabola above 0. Above 0 is where we had it in red. So that means if I put my solutions on a number line, I'm going to do my number line over again because it got so messy. Negative 4, positive 2. It's exactly 0 to negative 4. It's exactly 2 at a positive 2. But if we put inputs that go to the right of that, our graph, since it was smiling, was bigger or above. And also when we went to the left of a negative 4. So there's my solutions graphically. Now I'm going to record my answers in interval notation. In interval notation, we go from a negative infinity up to a negative 4, include the negative 4, so square bracket, union it with 2 to infinity. Sorry, didn't get infinity or square bracket. We're going to include 2, so it's 2 to infinity, parentheses. Here's interval notation. Here's your graphical solution. Here's a method of solving for x. Now I'm going to go just a little bit longer on this video because I'm going to show you that I could have solved this rather than factoring. I could have solved it by completing the square. So I'm taking this exact same equation. I'm going to set it equal to 0, but I'm going to find those zeros by completing the square. So it's x squared plus 2x. Complete the square. Balance equals 0. Half of 2 is 1. 1 squared is 1. So I add 1. Add 1. Take that back. I don't want to add 1 there. I want to balance it. So this is plus 1. So I want to subtract 1. Now it is x plus 1 squared equals minus 9 equals 0. Then I want to solve it for x. So if I solve it for x, then I want to isolate this x. So I'm going to go x plus 1 squared. I'm going to add 9. Then I'm going to get rid of the squaring by square rooting. So it's plus or minus 3. It's taking the square root of both sides. And then it's x equals negative 1 plus or minus 3. Now if I do the plus 1, I got negative 1 plus 3, which is 2. If I do the minus 1, it's negative 1 minus 3, which is a negative 4. I got the same zeros that I had doing factoring. If I ran through and did this with a quadratic formula, I would get the exact same answer. So no matter which method you choose, in this case you could factor, you could complete the square quadratic formula, you're going to get the two same really important points, which were negative 4 and 2, that tells you where it's exactly 0. Then draw your curve. It's either going to smile or frown based on your leading coefficient. Since this one was positive x squared, it smiled, and you can clearly see where your curve is above those anchor points of 0. That's your interpretation that you have to make with your inequality sign. So a little longer on that one. The next ones I'll be quicker.